Welcome everybody to your first video lesson for Algebra 2. This lesson will be on solving equations. We'll be going through section 1.3 of your textbook. Our learning target for today will be hopefully by the end of this video and by the end of the class period, we will be able to solve equations with variables on both sides. Okay, before we go through and get into the nitty-gritty of solving equations, let's go through a few key terms. Now, some of these key terms are from things you should have learned in algebra and from sections previous to 1.3. So since we're starting off with this section, we'll take some time to go through some of these. So first, the first key term we have is a variable. A variable is defined as a letter or symbol that represents something that changes. Okay, whereas our second key term is a constant. A constant is a value that does not change. So in algebra, a constant can be represented as basically just a plain old number. Take for example like the number 2 or the number 4. Those numbers are constant. They're not changing. They represent a specific value. However, in algebra, we may be dealing with certain values that may be changing, that may not be constant, and we call those variables. And we represent variables with a letter or a symbol. Could be a letter of X, could be Y, could be W, Z, M, or any other letter we want to choose. Okay? Could also be represented by some sort of symbol. Take, for example, you can use a triangle. You can use an angle symbol, okay, different sort of symbols that represent a variable. And the key thing here is that the variable represents a number that can change. So, for example, if we use X, X could represent 2, X could represent 4, X could represent 6, it could represent any number. Now, where this comes into play is when we write an algebraic expression. An algebraic expression would be something that contains variables. So that means a letter or a symbol, a constant, some number or value that doesn't change, and operators. What is meant by operators is things like addition, subtraction, multiplication, and division. Those values represent operations. So an algebraic expression would be something, for example, like this, 2x plus 4. Okay, this would be an algebraic expression because it represents, or it has in it, within it, a variable of x, constants of 2 and 4, and an operation of addition. This would be considered an algebraic expression. Now today we're focusing on algebraic equations. So an equation is signified by a symbol represented as an equal sign. So for example, A equals B is basically equation. Okay? So it's a formula of A equals B where A and B represent algebraic expressions. So, A, for example, could represent an expression of 2x plus 4, and we can set that equal to another expression, say, of x minus 2, and that's going to represent an algebraic equation. Equation because we are setting these two things equal to each other. So basically what an equation tells us is that the side of A is equal to the side of B. Now with the variable x in there, x is going to represent some number that usually satisfies this equation, and that's where we get into the last key term, which is a solution. A solution is a number or multiple numbers that make the equation true. So in the case of this example of here, of 2x plus 4 equals x minus 2, the example we have there, x is going to represent some number, whatever it may be, and that number is going to satisfy this equation. And that's the purpose of this lesson here, is we are going to be taking these algebraic equations and we're going to try and find that solution, that number that satisfies that equation. Alright, next we're going to go through some examples of solving equations. Now, if you've read the textbook, you'll notice that I've skipped a few things, such as the properties of equalities. We will go through those in class. As I go through these examples, since this is the first video lesson, there may be some things that you will need to kind of refresh your mind on, things that maybe you haven't covered since algebra. All right, so please follow along. If at any time you feel that I'm going too fast, you can always remember that this is a video that you can always pause and rewind to make sure that you get all the steps down. Okay, so let's start by solving this first equation. So what we have is an equation. We have 2x plus 6 minus 4x plus 5 equals 0. So again, just kind of going through the key terms. On the left side, this would be represented as an algebraic expression, and 0 is also an algebraic expression. Notice again how it contains both constants, which are the numbers, variables, which are the x's, and operations, which you can see there. So this represents, since we have the equal sign, an algebraic equation. Okay, so now we're going to solve this equation. When we're representing solving, notice that we have constants, which are just values, and we have operators. But the thing that we are looking for is we want to solve for the variable. So the variable we have in this equation is x. So our goal when solving this equation is to find out what that variable represents. I want to know what does x equal, or what value of x satisfies this equation. Meaning 2 times what number represented by x plus 6 minus 4 times what number represented by x again plus 5 equals 0. So I need to find the value of x, the same value that I can place for those two x's, that will give me as a result, when doing all these operations, will give me 0. Our final goal is to figure out that 0 equals 0. Okay? That the left side with those variables and constants is going to represent 0 in the end. And it's going to be equal to 0 on the other side. That would represent an equation. Okay, so the first thing you want to do when solving an equation is, the first step to always remember is to combine variables, or sometimes refer to it as like terms. So combine like terms. Like terms represents combining variables. Like terms can also represent combining constants. So if we look at this equation, let's start with the variables. We have two variables, x and x. So we have here 2x and 4x. So what I'm going to do is I'm going to combine these two things, these two like terms. To help you visualize this, what I'm going to do first is just reorganize the equation such that the two like terms are next to each other. So I have 2x, and notice here I have negative 4x, which would be the same thing as saying minus 4x, plus 6 plus 5 equals 0. Okay, the reason why I'm doing this is just putting the like terms next to each other. It helps to kind of simplify this expression and therefore solve the equation. So now that I have the like terms next to each other, we're going to start with the first variable, which is x. So I got two terms that have x in them, 2x and 4x. And I'm going to perform the operation that's shown. So here I have the negative symbol, or the minus sign. That's going to tell me I'm going to take 2x and subtract from it 4x. So 2x minus 4x would give me a negative 2x. Okay, so now I've combined these two terms to give me negative 2x. Okay, then I'm going to add to it what I have here. I'm going to combine these like terms of 6 and 5. So 6, positive 6 plus 5 is going to be represented by a positive 11. Then I'm going to set that equal to 0. So I've taken the 2x and 4x, combined those, and the 6 and 5, and combined those to 11. I've simplified now this expression as one variable, two constants, and one operator. Now simplifying this even further, what I'm going to do is try and solve for x again. So to do this is you're going to try now, since I have x on one side, I'm going to try and get x on one side and every other thing on the other side. So to do that, I have 11, and what I'm going to do is I'm going to take 2x and I'm going to add it to the other side. Okay? Now by adding it, what I'm doing is I'm taking this expression, if I have negative 2x, by adding this expression here of plus 2x, this is going to force this to cancel out. So the negative 2x plus 2x is canceled out. Think of it as negative 2 plus 2 is going to give me 0. But the thing to remember is that whatever I do on one side of the equation, I must do on the other. So if I added 2x to the left, I must add 2x to the right. Okay? That's one of the properties of equalities they have to pay attention to. So I'm left with, since this canceled out to be 0, I have 11 left over on the left side. Now on the right side I added 2x. Okay? So now my equation is, and you can rewrite it like this, 2x equals 11. Okay, now the last thing I want to do, since I have x by itself on one side, is I'm going to solve for x. So I have 2 times x equals 11. To get x by itself, I want to perform an operation to get rid of the 2. Okay, so if I'm multiplying by 2, the value I'm going to, or the operation I'm going to do is to divide this by 2 to get it to cancel out. Divide it by 2, and what I'm left with is x equals 11/2. And that solution is the answer that basically solves this expression. Okay, one way to check your solution always is you can always take this value and plug it back in. So 2 times 11/2 plus 6 minus 4 times 11/2 plus 5. If I were to check this algebraic expression, we're going to hope that it's going to add up to equal 0. So let's see what we get. Okay, I'm just going to look at fractions. So 2 times 11/2. Here the 2's would cancel out, and I'd be left with 11 plus 6 minus 4 times 11/2. So here, if you think fractions, the 2 would cancel with the 4, leaving 2 there. So I would have 2 times, so minus 2 times 11 plus 5. Okay, so I'm going to simplify this operation here of 2 times 11. That's going to be 11 plus 6 plus, mistake there, minus 22 plus 5. Now I can combine like terms. So if I combine, let's say I'm going to combine all the positives. I have 11 plus 6. It's going to give me 17 plus 5 minus 22. 17 plus 5 would give me 22. And then I get 22 minus 22, which equals 0. And notice here how this matches the expression, or the equation. We have 0 on the other side. So therefore 11/2 is a value that fits and solves this equation. Okay, a little longer process on this first one, but I wanted to make sure we kind of go through this thing and kind of refresh our minds on actually how to solve and simplify these expressions and equations. All right, let's move on to the second example. So this one we are going to solve for x. So our equation we have is x plus 2 divided by 4 is going to equal y. Now the one issue with this that you may notice right away, okay, with this, look at both sides of the equations. Our expressions on the left, x plus 2 divided by 4, and on the right we have y. Now the big concern you have for this problem is notice that you have two variables. You have both x and y as variables in this equation. Now, we will get to later in this year how to solve equations with multiple variables. So I'll skip on how to solve that now. But let's just work through the problem like we just did in the previous example. Our goal is again to solve for x. Okay, so we're going to solve for x in this equation. So we're going to solve it just like we did before. Okay? The biggest thing here to note is that when you're solving for a certain variable, you want to get x by itself. Make sure that x is alone on one side of the equation. So, looking at the right side, or sorry, the left side of this equation, I have x plus 2 divided by 4 equals y. So I want to get x alone. I want this thing to be by itself. So, here's where order of operations comes into play. I have x, I'm adding to it 2, and dividing by 4. So if you think of order of operations, the first thing you would normally take care of are things in parentheses or brackets or anything like that. Then you're going to go to powers. Then you're going to go to multiplication or division. And then lastly, you look at adding or subtracting. So here we don't have any parentheses. We don't have any powers. We do have multiplication, division. We have divided by 4, and we're adding, subtracting 2. So we're going to do the division first. So we have x plus 2 divided by 4 equals y. So to get rid of, to get x by itself, the first thing I want to get rid of is the divided by 4. Okay? I can't really do anything with the x plus 2. I can't get x by itself if I have it divided by 4. So the first thing we're going to do to get rid of this is we're going to take both sides of the equation, just like we did in the previous example, and to get rid of divided by 4, I am going to multiply by 4. Okay? Let me rewrite this instead of an x. Let me put this as a dot. We're going to multiply by 4. Okay? So, you're going to take this, multiply it by 4, and what that's going to do is it's going to cancel out the 4. But remember, whatever I do on the left side, I must do on the right side. So now I'm going to multiply the right side by 4. So my expression becomes, or equation, I'm sorry, is x plus 2 is going to equal 4 times y. Okay, and again, I'm trying to solve for x. So I still have x plus 2. Next thing I'm going to do is I'm going to take the plus 2, and to get rid of this, I'm going to have to subtract 2. I'm going to do the opposite expression, opposite operation. So I'm going to subtract 2 there. Here, 2 minus 2 will drop out and be 0. So what I'm left with is x. And on the other side, I have 4y, and I'm subtracting to it minus 2. Okay? Now, can I go any further? Can I simplify any further? The answer to that question is no. Because remember, notice what I'm doing here is I'm combining like terms. So I'm taking real numbers or constants, and I'm performing operations with them. But I can't combine these two terms because one has the variable y, the other does not. So I can't just say 4y minus 2 is equal to 2y. I can't do that because 2 does not have y in it. So 4 is multiplied by an expression or a variable of y, and then we're subtracting a constants. So the one thing to remember here is you can't combine variable, or you can't combine a variable with a constant. You must combine like variables, and you can only combine constants together. So in the end, this becomes our answer. X is going to be represented as 4y minus 2. Okay, this is our last example for this lesson. We have Bob the Builder designing an ideal bedroom. He wishes his room to be twice as wide as it is long. However, he only has 48 feet of drywall total to finish his room. So given this information, what should the dimensions of his room be? So if we think of what is meant by the question dimensions, anytime you think of a room, you normally give a room's dimensions according to its length times its width. Okay? Think of 12 by 10. That means I have a 12-foot room in length and a 10-foot room in width. So they give it in terms of length and width. Let's start with what we're given. We know that we have 48 feet of drywall that we need to finish off this room. Okay, so if I were to draw just a quick sketch of the room, simple as this. Okay, let's say that the length is represented here and the width is there. Okay, 48 feet of drywall. You got to think of what or how that's going to be used. When you're finishing off a room, you're not just going to do 2 walls of the room. You're not going to do this and this, but you're going to do all 4 walls of the room. Meaning you need the width and the length of each of the 4 walls. Okay? So, if we think about this, what we're really looking at, if I have 48 feet total and I have the lengths and the widths, if I were to take this information, what I want to do is I want to come up with an algebraic equation. So the simplest equation, if I know I have 48 feet of drywall, that's the total amount I have to complete all 4 walls. So if I take all 4 walls and say I take the length plus the width plus the length plus the width, that's going to give me 48 feet. That's the total amount that I have. So what are we really doing? Well, this question is really looking at the perimeter. Okay? Perimeter is the sum of all the sides of whatever shape that we have. Okay? Now, kind of simplifying this expression. Notice I have 2 L's and 2 W's. So what I can do, just like we did in previous problems, is combine like terms. So instead of having numbers or constants and variables, I have 2 variables, L and W. So I can combine these. So I have L and L, but both are positive numbers, so I can combine these into 2L. Same thing with the W's. I can combine those into 2W and set those equal to 48. Okay, so this is the algebraic expression or the algebraic equation that I can use to solve. Now our goal is I actually want to get a number for these dimensions. Okay, so what I need to do is I need to think a little bit harder with this. And let's look at the first sentence we're given. Not Bob the Builder designing an ideal bedroom, but he wishes his room to be twice as wide as it is long. What that is saying is that, let's say I have a length of 6 feet. What that expression says is that if my length is 6 feet, Bob wishes his room to be twice as wide, meaning the width would be 12 feet. So I can use that sentence to come up with another expression. Okay, really another equation. So what this is going to tell me is that if I think of it, my width is always going to be twice the length. So now starting with that, one easy thing I can do then is let's just redraw the picture. Don't want to do that. If I redraw the picture now, okay, I know that I have my two lengths, and what I just said is that my width is going to be twice the length. So I can put 2L and 2L. What this does is it kind of gives me the same expression I had up here in blue. Okay, it gives me the same expression I had here, but now I can rewrite it. And I can say, okay, if I think of the perimeter again, if I add all sides, I have L plus 2L plus L plus 2L. It's going to give me 48. Again, looking at the perimeter. Now notice now this is a lot easier because I have, instead of 2 variables, I have only 1. So I can basically add all the variables on this side of the equation, this expression, and simplify it down. So L plus 2L, this gives me 3L, plus L plus 2L is 3L. I can combine these. 3L and 3L is going to give me 6L, and I can set it equal to 48. Then, this is a lot easier. Now we can solve for L. Again, if I'm multiplying by 6, the way to get rid of it is divide by 6 to each side, and then I'll get L is 48 divided by 6, which is going to equal 8 feet. So that's my length. And if my length is 8 feet, what we know then, and I'll do this in red over here, is that Bob wishes his width to be twice the length. So here the width will be twice 2 times 8 feet, which tell me that the width of his room is going to be 16 feet. So then his dimensions, length times width, would be 18 by 6. So notice here there's multiple ways we can go through this problem, but again it's setting up one of those dreaded word problems to basically solve an algebraic equation. Okay, and this will conclude your first video lesson. Hopefully by going through this, you kind of have a better sense on how to solve algebraic equations.